Okay, with these we're asked to solve these systems of equations. And this particular system we're looking for x, y, and z. And the very first thing that we want to do whenever we're trying to solve these is convert this one to what they call an augmented matrix. In other words, just basically take all of the coefficients is what we're looking for here. And to create a matrix off of this. So the coefficient here would be -1, the coefficient here would be -1, 1. And then we do put this 4 in there as well. So if we create the augmented matrix, it would look like this. And you'll notice that each one of these correspond. Here's my -18, that's over here, the 0's here, -5 is right over here. So basically all I took was the coefficients of each one of these variables here, and then the answer as well, and I wrote that in here. Now then you can work your way through this whole thing, and the goal here, if you're doing it by hand, is to get ones all in the diagonal here. Okay, so if we get ones all in the diagonal, then you do all your work, and your answer should be -5, 4, and 3. Well, I'm going to show you a shortcut using your calculator, and this doesn't work if I asked for you to do it by hand, because that's the only way that you'll get credit for it. But if I allow you to use the calculator, and I do on some problems, then you can plug this one into your calculator. So we're going to show you using the TI-84, and we're going to do the same problem here. Let's clear this one out. Okay, so here is our matrix right here, and this is the matrix of this one here. Let's move this out of the way just so that you can see that this matrix here is the same one as the one I've got up here. I just kind of wrote it over here to the left, and that way my calculator wouldn't cover it is all. Alright, so I'm going to type in this matrix here into my calculator, and I'm going to put it in what we call reduced row echelon form. And what reduced row echelon is it's similar to this setup right here with all the ones going straight down the diagonal. The difference though is that there will be zeros here as well. This will help us determine what the actual answer of this one is. So let's kind of go through it here. This particular one is a 3-row, and it's got 4 columns, so it's a 3x4 matrix. The matrix button on your TI-84 is right here above this x to the -1. It says matrix right above it, and that matrix is in blue, indicating that we have to hit the second button first. So we go second, x to the -1. This brings up our matrix menu, and I've got a couple in there that I've already entered in, but we're going to change those anyway. And we're just going to do a matrix A. And what we want to do is edit that matrix. So we're going to go over here, not to math, but to edit. We're going to hit enter. We're going to edit matrix A, and this is currently a 3x4, but I need it to be a 3x3. I need it to be a 3x4. So if we do that, let's do a 3x4. So this is 3 down, 4 across what we're looking for. So I'm going to go 3x4. And I just hit enter, and notice how this automatically added an additional column onto this one, and they're all zeros. And these numbers don't match up with what I've got here, so I need to enter the correct numbers in here. And I'm just going to go down and I enter one row at a time. And this is -1. After every one that I enter, I hit the enter button, and that automatically moves it to the next column. Alright, so we got -1, -1, and I'm just going through each one of these here. Okay, -2, -18. And you'll notice after I enter it into the last column there, it automatically jumps to the next row, which makes it kind of nice. Okay, so I've got this one all entered in, and this is my matrix here, and we'll just double check here to make sure I didn't make any errors, which I sometimes do. Looks pretty good there. Okay, so I'm going to go second quit. This will just get me back to my normal home calculator page, if you will. What I'm looking to do here is we're calculating it using the rref, R reference, okay, which is what that stands for, is reduced row echelon form. Alright, so we're going to go back to our matrix menu. Again, that's the second x to the -1st power. This time, instead of going into edit, that's what we did last time, we're going to go into the math function of it. So that's 1 over to the right. And we're looking for the one that says rref. So I'm going to scroll down here. And we're going to scroll down for a little while. And there's, whoops, A is reduced, a row echelon form, excuse me. B is reduced row echelon, and reduced row echelon makes it easier. It goes a step further. We don't have to do any more calculations to it. So I'm going to hit enter on that one. That's option B. Notice that it says reduced row echelon form here. Then I needed to find the reduced row echelon of a particular matrix, and that was the one I entered in. It was matrix A. So I'm going to go in here and I'm going to hit second matrix to pull up my matrix menu again, and this is the one that I entered in, matrix A. You can hit the number 1 or you can hit enter. Either one works. So there's I want the reduced row echelon form of this matrix A. I'm going to close the parenthesis and I'm going to hit enter. And here is my reduced row echelon form. And if we were to write this one out, this is like our x equals -5, y equals 4, and z equals 3. So we've already found out what our z value is, our y value, and our x value all right here. And if we look, I'm going to pull this aside. Let's see, maybe I'll pull it. I'm not finding a good spot to move it around. Sorry about that. Let me reduce that one. We'll just kind of drag it out of the way. You look here, x value is -5, so let's pull this one back into my screen here. This is x. This is essentially 1x plus 0y plus 0z equals -5. So this is x equals -5. Y equals 4. We'll pull this one aside here and we'll see that yes, y did equal 4 as well here. And z equals 3. So this one did all the calculations for us. We didn't have to run the risk of getting all these simple mistakes that we sometimes make as we're trying to calculate this one by hand. The calculator makes it really nice. This is a good way to check your answer on all of your problems, even the ones I require that you do by hand. This is a good form to do it. When you get these all in a diagonal, the big thing is this is 1z equals 3, 1y equals 4, 1x equals -5. So that's going to be your answer. You'll still write it as this in the ordered pair here. I guess this isn't an ordered pair, it's an ordered triplet, but you'll end up writing it just like this. It'll be fine.